When working with translating to inequality notation, it may be helpful to visualize what part of a number line is referenced before translating to inequality notation. We're going to look at a few common phrases, but it might be helpful if we substitute a number in. So let's look at the number 10. If we say at most 10, that means on a number line we can't go past 10 to the right of 10 on the number line. So we can include 10, but that's the maximum, that's the most. So anything to the left of 10 would be included. If we were going to just draw this, we would fill in the dot and it would be an arrow to the left. Likewise, with the inequality symbol, this is an inequality pointing to the left. Notice that if we set this up, we have our inequality symbol pointing the same direction as the graph is going. Since it includes the endpoint, we put a line under it to represent or equal to. And we say this is bounded on the right, meaning you can't go past 10 or to the right of 10. So we say it's right bounded. And our interval notation for this would be a bracket bounded on the right. If we say at least 10, this is again starting at 10, but this time our minimum value is 10. We can include 10, but we have to go to the right of 10. We cannot include values less than 10. So our arrow would be a filled in dot at 10 with it pointing to the right this time. Similarly, our inequality would point to the right with an equal line under it to include the value of 10. This one we say is left bounded, and so our interval notation bracket would be closed to the left. If we say exceeds 10, this means that you can go to the right of 10, but you cannot include the actual value at 10. So you can include 10, but you can go to the right of 10. So that's what exceeds means. It can't be equal to, it must exceed it or be greater than it. This would be an open dot at 10, but with an arrow pointing to the right. This would be similar to an inequality opening to the right, but without the include equal to or equal to line. We also say that this is left bounded, but instead of a bracket we use a parenthesis because we do not include the endpoint. Is less than 10 means that on a number line we cannot include 10 once again, but we can take everything to the left of that point. So this one is an open dot with an arrow to the left. Its inequality points to the left, and it is right bounded with a interval notation parenthesis bounded on the right. That's a lot of notation, but those notation pieces will help when you're given an example. So this first example is n exceeds 42. So we'll go ahead and graph 42 on here. If it exceeds 42, that means we cannot include 42, and exceeds means it's greater than. So we need to take the values to the right of 42 and not including 42. If we were going to write this as an inequality, it would be n is greater than 42. Now let's look at 9 times n exceeds 42. How would you write that? Let's transfer this or translate this from English to a math inequality. We take 9 times n and we say that is greater than or exceeds 42. In interval notation, this inequality would be from open parenthesis 42, comma, infinity, close parenthesis. If we wanted to solve this inequality, we would have to divide by 9 on both sides, and n would then be greater than 42 over 9. The interval for this would be from 42 over 9 to positive infinity. If we look at example 2, a is at most 80, so we'll put 80 on our number line. We know that at most means we can include 80. If it's at most 80, that means anything to the left can also be included. We would write this as a is less than or equal to 80, and the interval that this would be on would be negative infinity to 80 with a bracket. It's a right-bounded bracket. Now, let's try negative 3 times a is at most 80. So we know it's less than or equal to 80. Now we solve for a by dividing both sides by negative 3. Whenever we divide or multiply by a negative, we have to flip our inequality over. So this becomes a greater than or equal to. And now this 80 divided by negative 3 becomes a number that is negative. Since these do not reduce, our solution set or interval where a is true is anything to the right of negative 80 over 3. And we would include the 80 over 3. So a left-bounded bracket, negative 80 over 3, comma, infinity, and a right-bounded parenthesis.